Hey guys, welcome back to another video, and today we're going to be making a really simple Python program which takes a normal image and converts it into an image made completely out of ASCII characters. So what do I mean by that? Alright, so let's just take a look at this one image I have over here. So it's an image of the Golden Gate Bridge, and this is how it looks like. It's in color. And now what we're going to do is I actually wrote our script, so I'm just going to run it. So python 3 main.py, and so as you can see, it's completely, these are all ASCII characters. So let's zoom out a bit and let's see how this looks like. And as you can see, that's the Golden Gate Bridge. It's a pretty good representation. And yeah, so let me just show you one more example. Let me open up this picture over here. So this is an image of me. And if you look up here, you can see it and it's pretty good. So yeah, let's see how we can do this. And altogether, it's a pretty simple process, and yeah, before I get into the code, let's kind of just run by the steps that we might need to do in order to complete this task. All right, so we have this image over here, and it's an RGB image. So if you look at this, or if you zoom in, you can see that each part is made out of these tiny pixels over here, right? You can see kind of small boxes, and each of those pixels have RGB values. So RGB value just stands for red, green, and blue, and so using just those three colors, you can make up any color that you imagine. So all of these pixels over here have certain RGB values. So what we're going to do is we're going to use those RGB values, and using those RGB values, we're going to come up with some sort of index which is going to tell us how bright something is. So for example, this part over here might be bright, but when you go to the ending over here, which is a little darker, that might not be as bright. So we need to come up with some sort of way which tells which pixel is bright and which pixel is not as bright. And using that, we're going to replace each of them with characters. So for example, if you look at the dollar sign, this actually could be used to represent some sort of darker color, right? So if there's something which is not bright at all, we could use the dollar sign to represent it. But if we want to represent something which is really light, we could use maybe an apostrophe, or we could use a period or a comma or one of those characters to represent lighter objects. So that's all we're doing. We're first going to convert our image into some sort of brightness index, and we're going to use that brightness index and replace its value with some ASCII character. All right, so let's start doing that. All right, so to start off, you just need a few packages. So you need to pip install OpenCV. So OpenCV is going to be used to work with our images. So this is how you install it. So pip3 install opencv-python. Okay, for me, it's already satisfied. And the other thing you want to install is NumPy. So NumPy is going to be used to kind of manipulate the numbers. All right, so once you have those two installed, we can start writing the code. So let's start off by doing our basic setup and initialization. So we're going to start off by importing the necessary packages. So in this case, CV2 and NumPy. So now what we're going to do is we're going to take our image. So you want to give it the image path. So my image is in the same folder as my Python file, so I just gave the actual name of it, so goldengate.jpg. And now what I'm going to do is I'm going to use OpenCV to read the image. So image equals to cv2.imread, and you want to give the path of the image, and we store it in a variable, so I'm just going to give that variable name. After that, I'm going to resize the image. And the reason we're resizing is because our terminal is not that big, so you just want to make it as small as possible. So I just chose 100 pixels by 100 pixels, so that's how you do it. So cv2.resize, and over here you want to give what you want to resize. I want to resize the image, so I gave image. These are the dimensions of how big I want the resize to be. So for me, it's 100 by 100, and then we're going to give interpolation as cv2.interarea. And what interpolation is basically telling us how do you want to resize the image and how do you want to calculate the values of these new pixels. Okay, so after we do that, just to show you how this looks like, let's print out our image and the shape of how our area looks like. And after that, we have two more areas that we predefined. So we have a brightness array, and this array is going to have the same shape as our image array. So it's going to have image.shape 0 and image.shape of 1. So we're going to have a two-dimensional array. And we're also going to have an empty list for our ASCII image. And this is going to be our final product. So we're going to work with those later. But for now, let's see how our image and how the image.shape looks like. All right, so let's run our image over here. So python 3 main.py. Okay, so as you can see, we have a three-dimensional array. So it's 100 by 100 by 3. So why is it 100 by 100? Because, well, that's the shape that we want our image to be. And we did over here. So all our images are going to be 100 by 100. And what does the 3 over here represent? So the 3 over here represents RGB values. So the first value represents the amount of red we have, then the amount of green we have, and the amount of blue we have. So over here, for example, if you look at this single list over here, that represents 1 pixel. And these are the RGB values that make that single pixel. So as you can see, it's a pretty long array. And this doesn't print out the whole thing, but I'm sure you get the idea of it. And so first we have a list which represents each row. And inside of that, we have a list which represents each pixel. Okay, so now let's go on to our next step, which is going to be calculating the brightness of our image. So there's several different ways we can calculate our brightness. So the easiest way that we're going to be using is by taking our RGB values. So over here, there are 110, 114, and 99. We're going to add them all up and divide it by 3. And that way we're just taking an average of it, and that's what we're going to be using for our brightness values. And one more thing I want to mention is over here, this is actually a three-dimensional array, and this is why for our brightness, we're only taking whatever is at the 0th index and whatever is at the first index. And the reason for that is because we don't want, for our brightness is just going to be one value, but it's not going to be like our RGB, which has 3 values. So that's why we're just taking the 0th index and the first index. So 100 by 100, and np.empty is going to create a completely empty array for us. Okay, so now what we're going to do is we're going to iterate through each of our pixels. So first we're going to go inside each row. So this iterates through each of the rows in our image, and this line over here iterates through each of our pixels. So one pixel would be image. We go to whatever is at the X index, and then we go to whatever is at the Y index. So that's how we get each pixel. Now what we want to do is we want to find its average. And for finding its average, we want to take the average of all its RGB values. So in this case, we're going to take whatever is at pixel 0. We're going to take whatever is at pixel index 1 and at index 2. So this represents red, then green, then blue. And after that, we're going to add them all together. So we added them up. And after we add them, we're going to perform integer division with the number 3 because there are 3 instances of the variable. Because there are 3 values and we're finding the average. And the reason we're doing integer division is because we don't want to have any floating point values, just to make it a little bit easier. Okay, and after we find this average value, we're going to go to our brightness array. So our brightness area is currently empty, and we're going to go to that particular index. So X and Y, it's the same index as this over here. And we're going to give it the value of our average. So right now, let's print out our brightness and let's print out the shape of brightness to just see how that looks like. Okay, so this over here is our brightness array. And this is the shape of it. It's 100 by 100. We discussed that earlier. And each pixel has just one brightness value. So if you look at this, you can see that the top left, right? So this represents the top left, has a value, a brightness value of 242. And the maximum we can have is 255. And the bottom right has a brightness value of 128. So what does this actually mean? Let's just take a quick look. So if you can see over here on the top left, that color is almost as close to white. It's pretty light, right? So you can kind of tell that when you have a higher value, it represents more whiteness or just brighter colors. But on the bottom right is darker than the top left. So that kind of makes sense on why it's a lower value than what's on the top right. Okay, so now that we have our brightness array, we can move on to the next step, which is to create some sort of dictionary to map a specific ASCII character to whatever the corresponding brightness is. So there's several ways to do that, but let me just go through a pretty simple way to do that. All right, so now we're going to take the brightness that we came up with, and we're going to convert those to ASCII values. So this is the index or the values that I found, and these characters are arranged in such a way that it's from lightest to darkest. So if you look at this, you can kind of look at that. So over here we have tilde, I think that's what it's called. Over here, you have this sign. I'm sorry, I forgot what it's called. Then you have quotations, the comma, colon, and so on and so forth. So these signs in the beginning are a lot thinner. They're a lot smaller, right? So they're kind of used to represent the lighter values. But as you go to the ending, we have the hash sign. We have a capital M, a capital W, 8, and then finally the dollar sign. So these signs are a lot darker, right? So they kind of feel more chunkier. So that's what we're going to be using for our bigger values, right? So yeah, so this is the list that we're going to be using. And if I didn't mention it earlier, all the code is in the description, so you can just copy that over from there. So this is the values that we're using. And now we need to have some sort of way to map it. So I'm going to be using a pretty simple approach of using a dictionary in order to do that. So how are we actually going to do that? So first, I started off by creating an empty dictionary over here. And I have a variable called value set to 0, and its purpose is going to be evident soon. And after that, I have a value called increment. So in simple words, increment is going to help us to kind of categorize each brightness to the value. So for example, we know that something from 0 to maybe 5 would be for this, right? But something towards 255, the bigger numbers, would use something like the dollar sign, right? So the increment is going to be by how much we're going to change to go on to the next ASCII value. So how do we get that? So the maximum value is 255, and we're just going to divide that by how many ever ASCII values we have over here. And I think that value is around 63, 65. I'm not completely sure, but whatever it is, it's over here in the length of our ASCII values, and that's going to give us the increment. Okay, so now that we have our increment, we're going to go inside of a for loop. This for loop is going to iterate through each and every single one of our ASCII values. And what we're going to do is each time we iterate through it, we're going to go to our dictionary and we're going to add our value as the first iteration. So the value is going to be the first thing we have. And to our dictionary, we're going to add tuple values. So we're going to give it 2 values. So first we're going to give it the value, right? So that's going to start off at 0. And the second value that we're giving it is going to be the value plus the increment. So you can think of this as a range. This value is kind of like the smallest value we have, and this value is the biggest or largest value we have for something to be assigned a specific ASCII value. And this over here is going to equate to our x value, and the x value is nothing else but a specific ASCII value. Okay, and after we get that, we're going to change our value variable. So it starts off at 0, and how are we going to change it? So we're going to change it to whatever this value is, the ending. So we're going to value, and we're going to add the increment to it, and we're also going to add 1. So the reason we're doing that is so that there's no clash in values. So in this way, we're never going to have any repetition. If this doesn't really make sense, let me just print it out. You don't need this step. I'm just using this to show you how it looks like. So let's just run this real quickly. Okay. So as you can see, each of our values has an increment, has a set or a range, right? So for example, over here, we have the dollar sign, right? So if anything has to be the dollar sign, it has to be between a brightness level of 252 to 255. So let's scroll up over here. And over here, we have our apostrophe. So for anything to be an apostrophe, it must be equal to 8 or 11 or anything in between those two numbers. So this is the range of numbers we're using. And this actually fits everything perfectly for us. So yeah. Okay, so let's go back to our program and let's now go on to our next step. So this over here is going to be our last step right before printing out our final result. So what we're going to do is we're actually going to assign our values. So doing that is pretty simple. So first we're going to iterate through each row. And for each row, we're going to have a temporary variable. And this temporary variable is going to hold a list. So as you can see, so this is going to refresh to being an empty list each time we go on to a new row. So as you can see, it's temporary variable. It's just an empty list. So now what we're going to do is we're going to iterate through each of the pixels, or to be more clear, each of our brightness values. And so after we do that, we're going to get our brightness value. So we go to the brightness array and we iterate through x and then y. And then we're storing that in a variable called value. So now what we're going to do is we're going to iterate through all of the keys inside of our ASCII vowels brightness dictionary. So this over here gets the low value and the high value in the keys. And each time we iterate through this, we're going to check if our value over here is greater than or equal to the low value and is less than or equal to the high value. And if that is the case, that means that we've found the perfect value for whatever we need. And in that case, we're going to add that ASCII letter to our temporary list over here. So temp.append, and we're going to go to that specific value and add that to our temporary list. And after we get that value, we're going to break out of this entire for loop. So break, now we're done with this for loop over here. And after we're done with an entire row, so we're done iterating through a whole row, after that, we're going to append this temporary list, which contains a specific row, to our ASCII image array. So ASCII image.append temp, and then we go back over here, and our temporary variable is going to be created again as an empty list. We're going to do that for each row until we're done with the entire image. So now we have the last and final part, which is printing out our image. All right, so now we're printing it out, and that's pretty simple. So what we're going to do is we're going to go through each of our rows in the ASCII image, and we're just going to print out the row. So that's the first thing that I thought of, and there's a slight problem with this. So let me just show you what that is. Okay, so let's run our file over here. Okay, and I'm just going to zoom out. Okay, so let's zoom out. Okay, so we get the image, right? We can see the image, but there's so much space in between each of these characters, right? So what I'm going to do is, so if you look at our earlier image in the beginning, there wasn't so much space. So this is kind of really stretched out, and it doesn't look like the actual image. So to fix that, I did a small fix, which is instead of just printing one of the ASCII characters for each iteration, we're going to print 3 of them in a row. So this is how we're doing that. So x plus x plus x for x in row. So instead, if we have $1 sign, it's actually going to end up printing $3 signs. So that way our image doesn't look as spread out and it's more compact. And then afterwards, we're going to take this in a line, and then we're going to print it using the .join command, which prints out the entire list as a string. Okay, so instead, now let's run this and let's see how it looks. So let's run it. And as you can see the massive difference between both of them. This image is a lot crisper and looks a lot better. And yeah, so that should be it for the video. And finally, you could add quite a few additions to this. You could add color to it. You could add slight shades of different colors. You could find out or you could also come up with different ways to calculate the brightness, which might even be more effective. And yeah, so finally, thanks a lot for watching, guys. Do let me know if you have any suggestions or if you have any questions. And don't forget to like and subscribe if this video helped you. Thank you.